A volumetric pipette is used to measure 25 centimeter cube of, okay, if I am the student, I'll be keeping on highlighting the data as given. 25 centimeter cube of 2 mole per dm cube concentrated aqueous sodium hydroxide, which is this. Okay, fine. I know the volume, I know the concentration there. How do I know if the 2 is concentration or any other data? How did I say this is concentration?
Oh, wait. I realized my mistake.
Mm-hmm. Right, Kevin, would you mind telling me how I'm confirming that to be concentration? How do I know if that is concentration? Because nowhere they say the concentration is this.
The unit, Miss, mole per dm cube.
Exactly. Mole per dm cube stands for the concentration. See, you know. Okay, a burette is filled with dilute sulfuric acid.
Yes.
Right. Starting from the beginning, question says a volumetric pipette is used to measure 25 centimeter cube volume and this much concentrated aqueous sodium hydroxide. So this one, and then that is now put into the conical flask, which is shown here. Now, a burette is filled with dilute sulfuric acid. Over here, we have dilute sulfuric acid, which is this. Fine. The equation for the reaction is shown. The reaction requires 50 centimeter cube of sulfuric acid. So we know only the volume of sulfuric acid, but we know both concentration and volume required for sodium hydroxide, taken for sodium hydroxide. Right. Furthermore, that is the amount of sulfuric acid, volume of sulfuric acid to reach the end point. What do we mean by that word? What is end point? We have done it several times.
Miss, I found out how to do it.
Okay, great. What's end point?
When the reaction stops.
Right. I'm happy that you have found out the way now. Just check if it is matching with mine. Yeah, it is where the reaction stops, as you said. How do I know if it is where the reaction stops? How do I see? Or how do I know if it is the end point?
No effervescence, right?
No. Why do we think of effervescence here now? And this is titration, isn't it? Neutralization reaction between base and acid.
When the color
Exactly. Color change. Does the color change on its own, or do we have to do anything to see a color change?
We have to add the dilute sulfuric acid. It will change on its own when we mix.
It's this. Dilute sulfuric acid is not going to change its color on its own when it reaches the end point. Instead, we will have to use an indicator. Can you give me an example for an indicator?
Phenolphthalein.
Phenolphthalein. Yes. No worries. I really like the way you said it, and I appreciate your effort. Phenolphthalein, methyl orange. Can I use universal indicator for titrations? Is it a good idea to use the universal indicator?
No, miss.
Reason?
Because isn't that for acids and bases?
It's actually a past paper question, a past year paper question that asks us, why can't we use universal indicator? Why is it not suitable for titration? A titration should show a clear color change on the endpoint, but universal indicator is unlike the normal phenolphthalein indicator or methyl orange. It will have a range of colors that it shows for each of the pH levels, isn't it? When it is pH 7, it will be green. And then when it goes to 8, 9, 10, 11, 12, it takes the shades of the blue and then moves to the darker region, becoming purple at the end, isn't it? And then becomes yellow, orange, finally red when it is acid. So universal indicator has a range of colors that it shows for each of the pH, which means if we are adding universal indicator over here, it's not going to show a color change only on the endpoint. Rather, for every pH change, it will keep on showing different colors. Can you please repeat why can't we use universal indicator for titrations as indicator?
Because, miss, universal indicator has lots of different colors.
Mm-hmm.
For example,
Mm-hmm.
if it's pH is 7, it will be green.
Mm-hmm.
So then it will change to lots of different colors. That's what I miss.
That's right. Okay, very good.
Miss, can I explain how I did the question?
Yes, please.
Okay. First of all, I changed 25 to decimeter, and then I did 2 times 0.025.
Mm-hmm.
I got 0.05.
Okay.
When I got 0.05, I did the 2-to-1 ratio,
Mm-hmm.
and I divided it by 2, and then I got 0.02. I got then 0.025, the mole for sulfuric acid.
But this is volume. We can use the coefficient ratio only for the amount, number of moles.
Yeah,
0.025 is volume.
yeah, that's why I did miss 25 times 2, and I got
Okay, N is
0.05.
C times V. Is it the idea?
Yes,
Okay, what's the concentration?
up the 2.
And then
0.
0.025. That
Yes,
is,
I
yes,
got
now
an,
you're correct.
and then
0.050
0,
moles. All right,
and
very
yeah,
good.
and then I did the 2-to-1, so it would be 0.5
Hmm?
and 0.025 there.
Yeah, if it is 0.050, this has to be 0.0250 moles. What's next?
So then after that, I did 0.025 over
Mm-hmm.
the volume that is required, which is
Mm-hmm.
0.05,
Mm-hmm.
and then I got 0.5.
What's the volume?
0.05.
No. Okay, volume. Volume is 0.05. Yeah, because it is in decimeter cubes now.
Yeah.
Okay, if
See?
we do that, we will end up having.
Hey.
That's right. See, initially you said it's confusing. Now you ended up having the correct answer, isn't it?
Yeah.
Okay, so just keep your confidence up. You can do this, Kevin. Yeah,
Yeah.
not magic, not rocket science. Very easy. Chemistry is very easy. So just doing a quick recap on whatever we did. This is titration in which we were supposed to find the concentration of sulfuric acid. The only data given about sulfuric acid was this missing volume. And we were also given the data that of sodium hydroxide's concentration and volume. Using that, we can find the amount by rearranging the formula concentration equal amount over volume. We can find the amount. One thing that we have to make sure is the unit has to be in decimeter cube for volume. And you did that, which is very good. Coming back, now amount of sodium hydroxide is found, but then we do not need that. We actually need this because to find the concentration here, we need the amount of sulfuric acid, volume of sulfuric acid. Volume of sulfuric acid is readily given. Amount of sulfuric acid was the one that is missing. And to find out that, we used the ratio, the coefficient ratio from the balanced chemical equation. 2 in front of sodium hydroxide. The unwritten number is 1, that in front sulfuric acid. So if this is 0.050, half of that is this. Substituting that and substituting the given volume, you got the answer, which is A, correct. And you yourself did it, which means you cannot say that you don't understand titration questions anymore. Yeah?
Yeah.
Great.